let us start lecture 10. So today's topic is alternating series, right? So now what is alternating series? As it is clear from the name, we'll have alternating signs into that. That means one is of plus sign, another is negative sign, and so on. We'll have alternating sign, right? So a series with alternative positive and negative sign, with negative terms, is called the alternating series, right? It is called the alternating series. So we can have few examples of that. Let's say this one, summation n runs from 1 to infinity minus 1 raised to power n plus 1 upon 3 raised to power n, right? So if you expand it, what do you get? Put n is equal to 1 over there, you'll get positive sign upon 3. Then you put n is equal to 2 over there, so you'll get 1 by 3 square. Here you have negative sign, 1 by 3 cube, and so on up to infinity. This is something which we call it as alternating series, right? And there may be something like the plus minus sign of, right? So you put n is equal to 1 over there, you'll get 1 minus 2 plus 3 minus 4, so on up to infinity. So have a different test for altogether a different test in order to cater the issue of convergence or divergence of alternating series, right? So is that fine?
Yes, sir.
Yes, sir. So, yes, you want to ask something?
So means it can be GP also.
क्या चीज?
I'm saying that it can be GP also.
Yeah, it can be GP also. We don't care about that, right? We only care about the signs. That means one should be positive, another should be negative. So it should be alternating way, right? So it's just kind of switching plus minus plus minus plus minus. That's it. Okay.
Okay.
So that's what we. Let's move to the next thing. That how we gonna solve these kind of problems. For this, we have a separate test. We call it as Leibniz test. So we should write it as Leibniz test. So this is Leibniz test. So let's see how it works. So which is of the form summation n runs from 1 to infinity minus 1 raised to power n plus 1 un, right? So it is something like u1 minus u2 plus u3 minus u4 plus u5 up to infinite is convergent if following conditions are satisfied, right? So now you see that. So these are the three conditions. So the very first condition is your un should be positive. Un should be greater than 0 for all n greater than a fixed number. Of course, we always care about the tail. That's why. Okay. So second thing is what? Second thing is un should be decreasing, right? So that means un should be greater than equal to un plus 1 again for all n greater than equal to m. And the last thing is, if you take limit n tends to infinity un, it should come out to be 0. If these three conditions are fulfilled, then we say that this series is convergent. This alternating series is convergent, right? So I'm not going to do the proof of that. As I'm telling you, this is not the part of the syllabus, so I'm not going to do that. So let's say
Excuse me,
how
sir.
we gonna do. Yes, please.
Sir, is that minus 1 raised to power n plus 1 into un?
Yes, it is into UN,
Okay, sir.
right? Okay, so I should write it more clearly if you want. So let me put it over here, here, and here. Yes, then over there.
Sir, if any one of these conditions is not satisfied, then can we say series?
No. If one of the condition is not satisfied, then you cannot apply the test, right? True?
Yes, sir.
Okay, now see that. So let us take an example of this, that how to apply this test. Okay, so let's say take an example. Interestingly, the example is something like that. Summation n runs from 1 to infinity minus 1 raised to power n plus 1 to 1 by n. So you want to check that whether it is convergent or it is divergent, right? So that's how we're going to do it. So now see this. So you compare it with this thing, right? You compare it with this form. Okay, so if you compare it with this thing, so what is your UN? Can you tell me what is your UN?
1 by n.
1 by n.
Yes. So we're gonna check all these three conditions one by one on UN. So what is our first condition? So tell me, what is our first condition? UN should be positive.
greater than 0.
Greater than 0.
1 by n is greater than 0 for all n.
Yes, sir.
We
Yes,
care
sir.
about t, but we know that it is always true, right? Secondly, it should be decreasing, right? UN should be greater than the UN plus 1. That means UN plus 1 should be less than UN. So let me consider the difference of these two. So that means 1 by n plus 1 minus 1 by n. So that's what n minus n plus 1 upon n into n plus 1. And that's what minus 1 upon n into n plus 1. So is it negative or positive?
Negative.
Negative.
Right? So that means what? So your un plus 1 minus un is always less than equal to 0. So your any term is lesser than its preceding terms, its previous terms, right? Limit n tends to infinity un. That means limit n tends to infinity 1 by n. So which is what? 0. So now you see that all three conditions are fulfilled, right? True? Are you with me on this?
Yes, sir.
This, and finally this. So by Leibniz test. So by Leibniz test, summation minus 1 n plus 1 upon n is convergent, right? True? So always keep in mind that this is something which is pretty much singular. Leibniz test is not applicable anywhere except this exercise, right? So it is solely made for the alternating series. So if your series, for other series, you have so many tests like root test, ratio test, comparison test, and so many other tests as well. But here we have only Leibniz test for the alternating series specifically, right? So there is, like, I guess this can be easily remembered just because it can apply to a certain type of the series. Okay?
Yes, sir.
Okay. So let us move forward and let us see the remaining things in the exercise. It's not only about this. So let's do a few questions on this so that we'll come to know that how it works. Okay. So now this is also an interesting part. If you take the simply, if you take simply, if you don't consider this sign, then it will become a harmonic series, and your harmonic series is divergent. But if you take the alternating sign, then it is always what?
Convergent.
Yeah, always keep in mind, right? Sorry. So let's.
Sir, can you please repeat the harmonic point
So
again?
I told you that if this minus 1 is not there, if we don't consider the sign, we'll only take 1 by n. Then of course it becomes a harmonic series. It is divergent. We have done the proof of that.
Yes, sir.
So that's what I'm saying. There is a minor difference. If you take the alternate sign, it will become convergent. But if you take the only positive sign, then it will become divergent. Right?
Okay, sir. Got it.
We need to apply the Leibniz test in order to check that whether this is convergent or divergent. Right. So can you see that if you have un, so again by comparison your un is what?
1 by n square.
n. So take the first part, that means un should be positive. So that 1 by n square is always positive for all n. So the first part is quite obvious. So now you take un plus 1 minus un, that means 1 by n plus 1 whole square minus 1 by n square. So this becomes your n square minus 2n minus 1 upon n square into n plus 1 whole square. So this will get cancelled. Again, this is what? Less than equal to 0?
Yes,
So
sir.
your un plus 1 minus un is less than equal
Less
to
than 0.
0. So your un plus 1 is less than equal to un for all n. So we are done with the second condition. We have 1 by n square, which will come out to be what? 0, right? So all the three conditions are satisfied. So again, therefore, by Leibniz test or alternating test, summation minus 1 n plus 1 by n square is convergent. Right? Is it okay? Is it fine?
Yes, sir.
Yes, sir.
I take the part to be 3 by 2. Is it convergent or divergent?
Convergent.
Convergent.
Close.
Convergent.
You can quickly calculate in your mind that all the three conditions are satisfied. First, un should be positive. Second, what? U's are un plus 1 minus un are, it's less than equal to 0. It's clearly a decreasing thing. And the next part is, of course, limit n tends to infinity, un has to be 0. So by putting all these things together, we can say that summation minus 1 raised to power n plus 1 upon n raised to power 3 by 2 is something which is convergent. Okay, so let's move to the next question. Yes. So let's move to the next question. This is a slight variation of this thing. So that's why I'm just directly jumping to the question number 33. So that's what n raised to power infinite cos n pi upon n. Right? Do you think that these two are same almost?
Yes, sir.
Yes, sir.
Yes, sir.
Because this is what? Minus 1 raised to power n.
And
Right? And this is what?
N root 3.
And 3 by
3
2.
by 2.
Because this will also switch the signs, right? The only difference would be what? Here you will get the first sign to be negative and it doesn't matter, right? So we really take care about the switching of the sign properly, that it should change the sign at each step from plus to minus, from minus to plus, and so on. Is it fine?
Yes, sir.
Are you getting it?
Yes, sir.
Okay. So should I move forward?
Yes, sir. Yes, sir.
Okay. So let's see. Take another example. So that is summation n runs from 1 to infinity minus 1 raised to power n plus 1 by n. Right. So now think of all the conditions, right? So the first one. So your un is n plus 1 by n. These are positives. Okay. And secondly, you want to prove that the decreasing. Now there are two things when you want to prove the decrease part. One is un plus 1 minus un. You can do via that. And there is a shortcut as well. And the shortcut is what? You take it as a function. You replace n by x. And if you prove that the derivative is negative, So you take the division 1 plus 1 by x, and you take the derivative, it becomes minus 1 by x square, which is what? Negative. So if a function have a derivative which is, if a function has a derivative which is negative always, so of course this function is what? Decreasing.
Decreasing.
So therefore, corresponding sequence n plus 1 by n is decreasing, right? So this is also one way to prove the decreasing thing. If you have a complicated structure in place of un, so sometimes it is useful to implement the derivative rather than calculating the difference of un plus 1 minus un. Okay? So the third one is, you take limit n tends to infinity un. Now this is something which may get failed over here, and it will. How?
Yes,
So
sir.
n plus 1 upon n, which is what? Limit n tends to infinity 1 plus 1 by n. So that is what?
Yes, sir.
1.
1.
So which is not equal to 0,
Yes, sir.
right? So we cannot say anything. Cannot apply the,
Lebanese.
yes. We cannot apply the Lebanese test. Right. So, but as discussed, even one condition is not satisfied, we cannot use it. Okay. But we cannot say that either it is convergent or divergent. We cannot say anything about this. Right. We are not sure. We are not saying that even, the convergence can only be detected by the Leibniz test. Or if Leibniz test is failed, then it has to be divergent. So it's not like that. But yes, we can have something to, make a point. That's what. So we'll imply our nth term divergence test over here. And this can be implemented to your alternating series as well. So nth term divergent test. And for this, what we want, that limit n tends to infinity an. So the whole an is what? Minus 1 raised to power n plus 1, n plus 1 by n. It should go to 0, yeah, right? This is our necessary condition. Is it okay? This is our necessary condition, right?
Yes, sir.
So limit n tends to infinity minus 1 raised to power n plus 1. This becomes 1 plus 1 by n. Now, if your n is odd, then this thing will become even, n plus 1, right? So let me take it to another page. So over here, yeah. So if your n is odd, so n plus 1 will become even. So this minus sign will disappear, and we are only left with 1, right? And for even, it should become minus 1. So that means this limit is not going to 0. This thing is not going to 0. It should necessarily go to 0. So since it is not going to 0, so we are sure about the divergence of this. So we'll say that summation minus 1 raised to power n plus 1 into n upon n plus 1 is divergent, right? Is it fine? So Lebanese test doesn't tell us that whether it is divergent. So in order to prove the divergence, we need to adopt the different ways. Yes.
सर आपने ये कहा था कि अगर इन्फिनिटी में कुछ भी ऐड या सब्ट्रैक्ट करो इन्फिनिटी रहेगा, तो इसमें हम ऑड और इवन कैसे कंसीडर कर सकते हैं?
No, I'm saying that इसको करने का इसको सोचने का एक दूसरा तरीका भी है. वो थोड़ा टफ है, लेकिन तुम्हें समझ आ जाएगा. उतना टफ भी नहीं है. Okay? So you think that कि ये आ गया तुम्हारा n upon n plus 1. Sorry, actually यहाँ मैंने एक गलती कर दी है. यहाँ था n plus 1 upon n. Okay? So you have minus 1 raised to power n plus 1 into n plus 1 upon n. Right? Now you start putting the values. Okay? So you have value, you put 1. So it is positive sign. So it becomes 2 by 1. Now you put 3, it have a minus sign. Sorry, put 2. So it becomes 2 plus 1, 3. So it becomes 3 by 2. Right? So now you put 3, so it becomes 4. So 3 plus 1, 4, 4 by 3. And then you put 4, it becomes 5 by 4, but with negative sign. So you put 5, it becomes 6 by 5 positive, and so on. So if you consider these two things, right? If you consider negatives and you consider positives separately. So I want to claim, my claim is this is a different subsequence of greens, right? And this is a different subsequence of reds. So can you see that your green sequence is keeping on, is it's decreasing and decreasing towards what?
0.
No, 1. Yeah. So
1, yes, sir.
yes. So I would say that your greens are going towards 1. And what about the reds?
-1.
0.
-1.
Oh, sorry, -1.
Right. So we have, we have done a result that if you are able to find two subsequences which are going to two different limits, then your sequence is always divergent. Right?
Okay, sir.
Sequences such that one subsequence will generate the limit 1 and another will generate the limit -1. So by this argument, I'll say that my sequence is divergent, right?
Divergent.
So why I'm saying sequence, because this is sequences over here. When you talk about nth divergent test, you do not take the series itself. You take the only sequential part of the summation, right? Okay, is that fine?
Yes, sir.
Are you on this? Tell me, is it okay?
Yes, sir.
Yes, sir.
Absolute convergence. So a series summation an is said to be absolutely convergent if summations of mod of an is also convergent. Right? So then we say that, see, if this thing happens, then we say that series is absolutely, the original series, that is this series is absolutely convergent. Okay, so let's start with an example so that you will come to know that how it works. So now see this. So examples. So now think of this thing. It is what? Think of this thing. It is what? Can you tell me it is what? Is it a GP? Yes, it is alternating. Yeah, alternating series. Yes. Okay, it is alternating, true, but it is a GP, right? So let me put it over +1 in order to make the first term positive. However, it is not necessary to make the first term positive. So it moves like this, right? True.
Yes.
So what is what if you take the absolute values of this series, that means this, so it would be what? 1 by 2n. True. Now this will become what? Like this. Is it convergent now?
No, sir.
Yes, sir.
Yes, sir. It is
Yes,
convergent.
sir.
It is.
Still a GP.
Yes,
Still a
sir.
GP.
Yes, sir.
Common ratio half. So above we have a common ratio of -half. Here you have a common ratio of half. That's it. That's the only difference. Okay. So this is still convergent. Now the modulus part of this is absolutely convergent. Okay? See the second example.
Sir, what do we mean by absolutely convergent?
Yes.
What do we mean by saying absolutely convergent? Is there a difference between convergent and absolutely convergent?
Yes. I'll make my point. Give me 5 minutes. Okay. Okay. So now you consider this thing. N raised to power say half. So can I write it in this way? Right? Is it fine?
Yes, sir.
Yes,
Can you
sir.
tell me? Can you tell me is it convergent or divergent?
Divergent.
Can you tell me how it is
Divergent. Divergent.
Divergent.
Divergent. Test. Sir,
Which
test.
test?
P-test.
P-test.
Test.
That's what I'm saying, that you should take the each and every part of the statement very carefully. P-test is applicable only when your ANs are positive, but this is an alternative series. On alternative series, I've already told you there is only one test which can be implemented, that is Leibniz test, right? Now try to see it in this way, that it is an alternating series. Now tell me,
Sir,
is
by
it
Lebanese
Convergent.
test, it will be convergent.
Convergent.
Convergent, sir.
How convergent?
Sir, by Lebanese test.
And how you apply the Leibniz? Just give me the steps.
Sir,
And
How you
by
first
start?
root
We
10
see
is
that an
Sir,
plus
but
1 is great. The next
What is
term
your
will
it's
be
UN?
positive.
and by
Yeah.
root
What
10.
is your UN? Tell me what is your UN?
1 upon
One
root
by
1 upon root n.
Root
1
n.
upon root 2.
Yes. So these are UNs are positive,
yes, sir.
decreasing,
Yes, sir.
and
Yes,
as
sir.
n tends to infinity, UN goes to 0. So by
Yes, sir.
Leibniz test, it is what?
Convergent.
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 Right? So now, but if you take the absolute terms of this, if you take the absolute values of all the terms, so now can you tell me is it convergent or divergent? Now can you tell me is it convergent or divergent?
Divergent.
Why divergent?
Test.
P-test.
Now p-test is applicable, right? Because now it is no longer an alternating series. Now it is divergent, right? So you see that if you take the original series, it was convergent, right? But when you take the mode of this series, then it becomes what? Divergent. Right? But in the earlier example, whether you took the mode of this or you took the original series, it will come out to be convergent.
Convergent.
Right? Is it fine? So is there a difference between normal convergence and absolute convergence?
Yes,
Yes,
sir.
sir.
Yeah, somebody was asking. I was, my specific question was to him.
Yes, sir, I was.
You got it? You got it?
Yes, sir.
So now, that why we discuss the absolute convergence, the concept of absolute convergence in this particular section. Why? Because earlier we used to deal with the positive term series. So if your series has already positive terms, then you don't need to check about the absolute convergence, right? Because absolute will make no difference to them because they are already positive, right? Since now we are dealing with an alternating series, so minus signs are appearing. That's why we are talking about the absolute convergence. Is it okay?
Yes, sir.
Yes, sir.
Right? Now I'll make the last concept of this thing, and that is something we call it as conditional convergence. Conditional convergence.
सर पिछले क्वेश्चन में आंसर क्या हुआ फिर डाइवर्जेंट ना
एब्सोल्यूट के तौर पे डाइवर्जेंट, वैसे कन्वर्जेंट. आंसर कोई नहीं है, ठीक है, दो अलग अलग चीजें हैं.
ओके सर.
ओके, सो मैं अब बता रहा हूं कि अब मैं पूरा लिखूंगा कि अब एक्चुअली में दूसरे का आंसर क्या हुआ, वो हम डेफिनेशन में डील करेंगे. ओके, So right. So let's see. If a series summation an is convergent, but summation mod an is not convergent, then we say that summation an is conditionally convergent.
सर सर आई हैव अ डाउट सर अगर नॉर्मली किसी भी एक समेशन एन को हम बोल रहे हैं कि वो कन्वर्जेंट है तो सर उसका मतलब क्या हुआ कि वो कंडीशनल कन्वर्जेंट है या एब्सोल्यूट का मतलब क्या
नहीं
होगा?
नहीं, उसका मतलब सिर्फ ये है कि उसका इतना पार्ट कन्वर्जेंट है, दैट्स इट। मोड के बारे में हम कोई बात ही नहीं कर रहे, ठीक है। फिर हम मोड को चेक करेंगे, ठीक है। मैं तुम्हें एक ऐसे समझा देता हूं कि मान लो तुम्हें किसी ने कह दिया, लेट समबडी सेज यू दैट दिस इज कन्वर्जेंट, राइट? सो दैट मींस we are not sure about the modulus. So what do you need to do? You make summation mode and, right, if it is convergent, then you say that this series is absolutely convergent. Okay? And if it is divergent, then you say that this series is conditionally convergent. Right?
Sir, got it.
You got the point? Is it true?
Yes,
Yes.
sir.
सबको समझ आ गया?
Sir,
Yes.
if we can say that a series is convergent, then why do we have to take a part of it and prove that it is convergent or divergent?
No, we are not taking the part of that. We are simply, taking all the signs to be positive.
Yes.
Right? So part of that is, it's not a problem to deal with. Part of that, it's a word which is vague. It's hazy. You cannot, this doesn't make sense. Part of that is infinite, finite. What is that? So it's not about the part. See, the only thing is, earlier we used to deal with the positive term series. Okay. So there was no point to take the modulus of the series. Why? Because they all are already positive. Now, since we have started taking the alternating series, so it is quite obvious to ask a question. It is quite natural to ask a question that what happens if we take the modulus of the series? Okay? Is it fine?
Yes, sir.
Yes, sir.
So, should we move forward?
Yes, sir.
Yes.
Okay. Okay. So let's see this. So, we have already proved that this is something which is conditionally convergent. Now, somebody was asking now what to say about this. So, this is conditionally convergent. So, we'll do one more example to check the conditional convergence. This is question number 20. So, runs from 2 to infinite minus 1 raised to power n 1 by log n cube. Right. So first of all, we want to comment that whether it is convergent, divergent, absolutely convergent. What is that? Okay. So that's what we want to check. So let's say how we check it. So if you take the conditional if you take the convergence of this thing, now you know that it's an alternating series. So we need to apply the Leibniz test. So here your un is what? 1 by
C log n.
Right? So are they positive?
Yes,
Are they
sir.
positive? Okay,
Yes.
since we are
Yes, sir.
So,
0 for all n. So what about this? Is this decreasing?
Yes, sir.
Yes,
How
sir.
you
Yes.
decrease it? You simply take the function, right? 1 by log x cube. Now, you don't even take the derivative of this. You can do it, but you think of this thing. So this becomes 1 upon 3 log x, no? True?
Yes, sir.
Yes, sir.
Yes,
You
sir.
know that your log x is increasing,
Yes, sir.
right? Even 3 log x is increasing. Therefore, 1 by 3 log x is what?
Please.
Decreasing.
Okay. So now, third thing, if you take limit n tends to infinity, un, that means limit n tends to infinity, 1 by log cube, that's what? 0. So all the three conditions are satisfied,
Yes, sir.
right? So therefore, by Leibniz test, summation 1 by log n cube into minus 1 raised to power n, and n starts from 2 to infinity. Why 2 to infinity? Because log 1 will become 0, right? So the first term will not be taken in that way. So is what? Convergent?
Yes,
Yes,
sir.
sir.
So up to this point, can you tell something that it is conditionally convergent or it is absolutely convergent? Can you say anything about this?
No,
No,
sir. We
sir.
will have to check.
Yes, we'll have to check. Okay, so let's move to the next part of this. So we'll consider the absolute values from 2 to infinity, 1 by 3, 1 by log n, right? True? Now, it can be done in many ways. You can apply the integral test over here. You can apply the comparison test over here. Now see that how it works. You know this?
Sir, can you repeat? Your voice wasn't audible.
Sir,
It was
voice.
lagging.
Sir, it was lagging.
Okay. So this is your series, and you want to prove that this part is divergent, right? Or convergent or divergent, right? So
Yes,
now
sir.
you know that your n is greater than log n.
Yes, sir.
Yes, sir.
You know this relation very well.
Yes, sir.
Yes, sir.
Okay. So your 1 by n is less than 1 by log n.
Yes, sir.
Sir.
Yes, sir.
If you take the series of this part, whether it will be divergent or convergent, what will be that?
Divergent, sir.
Divergent.
Divergent.
So this is bigger than a divergent thing. That means it has to be divergent, right?
Yes, sir.
So
Yes, sir.
direct comparison test. Summation 1 by log n is also divergent. And if it is divergent, if you take 1 by 3, that will also be divergent, right? Is it fine?
Yes, sir.
Yes, sir.
Tell me.
Sir,
So now,
sir,
what do you
direct.
conclude? Just let me just put me my. I want to state a final word over here. So can you tell me what is that? Is it now conditionally convergent, absolutely convergent? What is it?
Conditionally convergent.
So you got the idea. So therefore, given series is conditionally convergent. Yeah.
Sir,
Yes.
can you again explain how it turned out to be divergent, please?
Yeah. See, I've taken this thing over here.
Yes, sir.
So your 1 by log n is greater than 1 by n.
Yes, sir.
If we take the summation on the both sides, this is already divergent.
Yes, sir.
So this series cannot be bigger than a divergent thing. It has to be divergent as well.
Yes.
So that's why it is divergent.
All right, sir.